Welcome to my channel, students. We were discussing about the theories of molecules. So we have just discussed the Vesper shell, valence electron pair repulsion theory and valence bond theory, and we were just about to start the molecular orbital theory. So today we are going to start this theory. So first of all, the postulates of molecular orbital theory. The first one is during the bond formation between two atoms, their half-filled atomic orbitals overlap. Only those orbitals will overlap which are half filled. If they are completely filled, it cannot overlap together to form molecular orbitals. The second point is when two atomic orbitals overlap, they form molecular orbitals. Now two types of molecular orbitals will be formed. One will be termed as bonding molecular orbital and another will be called as anti-bonding molecular orbital. The bonding molecular orbital has low energy than the atomic orbitals, while the anti-bonding molecular orbitals will have high energy than the parent atomic orbitals. Now electrons in the case of molecular orbitals, they are distributed according to the electronic configuration rules, that is Aufbau principle, Hund's rule and Pauli exclusion principle, and they are distributed in molecular orbitals in the same way as those for individual atoms. Now the orders of energy of bonding and anti-bonding molecular orbitals will be as following, that is sigma 1s is formed, so the sigma 1s will have low energy than sigma star 1s. Sigma star 1s is having low energy than sigma 2s, and sigma 2s is having less energy than sigma star 2s. Then it is having less energy than sigma 2px, it is having less energy than pi 2py. The energy of pi 2py is equal to pi 2pz because both the orbitals are degenerate orbitals. Now the energies of pi 2py and pi 2pz, they both are less than pi star 2py and pi star 2pz, and these all energies are less than sigma star 2px. The number of bonds formed between the two atoms is called bond order. Now we can find out the bond order in two different ways. The first one is we have to look at the total number of electrons in the bonding molecule and the anti-bonding molecular orbitals. So first of all, count the total number of electrons in bonding molecular orbitals and minus total number of electrons in anti-bonding molecular orbitals, divide it by 2. The desired answer, the required answer, which is 2, 3 or 1, that will give you the number of bonds which are formed by the molecule. The second way of finding the bond order is just look at the number of pairs. So the total number of electron pairs in bonding molecular orbital and minus the total number of electron pairs in anti-bonding molecular orbitals. Both cases will give the same result, but in one case there are pairs of electron, and the second case the complete number of electrons are considered. Now if we look at the example of formation of hydrogen molecule, then it will be further explained and you will come to know the postulates about the postulates. So first one, formation of hydrogen molecule. The atomic number of hydrogen is 1, so there is 1 electron in each hydrogen, that is 1s1. If you write down the electronic configuration, that is 1s1 for one hydrogen and 1s1 for the other hydrogen. So now these two 1s1, these are called as atomic orbitals. So I will write down that these are the atomic orbitals. This one and this one, that is also atomic orbitals. I will just write down it shortly, AO. Now these electrons, one electron will come from this orbital to the bonding and one electron will come from this orbital to the bonding molecular orbital. Both the electrons will pair here according to the Hund's rule and nothing is remaining, so the anti-bonding molecular orbital is now empty. Now a bond is formed between the two hydrogen atoms with the help of sigma S and S overlap, which is called as sigma 1s. Now sigma 1s bond is formed between the two hydrogen and sigma star 1s is the anti-bonding. Now this one is the bonding molecular orbital. while the one which is above, that will be called as anti-bonding molecular orbital. Now the bonding orbital is having less energy than the atomic orbital, while the anti-bonding is above the plane, so it is having greater energy than the atomic orbitals. Now let's find out the bond order of hydrogen. If we write down the bond order of hydrogen, so we are having one electron pair here in the bonding and no electron in the anti-bonding. So one pair minus zero pairs is equal to 1, or we can also find out it with the help of the second formula. There is 2 electrons in the bonding, 0 electrons in the anti-bonding, and divided by 2, and it is divided by 2, so 2 and 2 will cut up and 1 is the answer. Now as there is 1, so the bond between two hydrogen is a single bond, and that single bond will be called as sigma bond. So that is the evidence that hydrogen can exist in H2 form. Now there is another question, that why He molecule He2 cannot exist in nature. So that is explained by molecular orbital theory. Once you draw the structure, you will come to know that in case of helium, the bond order will be 0. Let's move towards helium. So how helium molecule cannot exist in nature. The question is normally asked in the paper that explain the existence of helium molecule in nature, or why helium cannot exist in the nature as He2, why hydrogen exists as H2 while helium as He but not as He2. Now this type of explanation, it has been given by molecular orbital theory. The atomic number of one helium is 2, so we are having 1 is 2 high with each helium. Which we draw the structure, then by drawing the structure we are having 2 electrons with one helium, 2 electrons with the other helium. These are 1 is 2, 1 is 2, and both of them they are called as atomic orbitals. Now what happens, one electron from this orbital and one electron from this orbital, they go towards the bonding molecular orbitals, and still one electron in both are remaining. Those one electron from this and one electron from this, they will move to the top, and there are 2 electrons in the anti-bonding as well. Now to find out the bond order, if you look at the bond order in case of hydrogen, so we are having 1 minus 0, so 1 was the answer. It means hydrogen can form a single bond. But in case of helium, we are having one pair of electron in bonding, one pair of electron in the anti-bonding, so 1 minus 1 is equal to 0. 0 means that no bond formation will be occurring in case of He and He atoms when they combine together. So it means that helium cannot exist in the nature in the form of He2, but it can only exist in the form of He. If we find out the bond order by using the second method, so we are having 2 electrons in the anti-bonding, 2 electrons in the bonding, so 2 minus 2 is equal to divided by 2 is equal to 0. Again the bond order is 0. When the bond order is 0, so no bond formation will occur in the molecule. Thus hydrogen is present in the H2 form, while helium can exist as He2 but not He but not as He2. This type of explanation has been provided by molecular orbital theory. The second type of explanation is the Doclet rule. In case of He2, it obeys the Doclet rule. It is already having 2 electrons. It is stable. So once it is stable, so there is no need for helium to form a bond. So that's why it exists as He but not as He2. Let's move towards another example.